Okay, folks, I want you to set up your notes just like you see them right here. And then what I'm going to do is I'm going to walk you through problem number one. So our notes today are going to be the beginning of our homework, and then every other problem is going to look exactly like this, going to have the same kind of format. All right? So hopefully after I do problem number one with you, it'll be a little bit clearer. And so what I'm going to do is I'm going to jump over to what it looks like. So it says, graph this system of inequalities. So we were practicing that yesterday by hand. We were graphing them. And today what we're going to do is we're going to use Desmos. We're going to just use technology. When you have, like the real world problems, they're all done using technology. But what we were doing yesterday and building our algebra skills, I think, is very, very important. And we're going to practice some more algebra skills right down here in this table. So Desmos is not going to do the table for us, but Desmos is going to do the feasible region for us. So let's go over that. What is the feasible region? Well, what you do is you open up the little Desmos file that I attached to today's assignment, and it's going to be having all of the inequalities here. Once I save it, and then I attach it to our assignment. But for now, you can only see this one right here. And, I don't like using this little menu here, so you're not going to see me open this menu up. But I guess you will right now. The inequality signs are there, but I just like using the ones that are on my keyboard. They're near the shift key, or, the shift and the space bar. And then if you go like here, what I did was I hit less than, so I hit the less than symbol. So shift and then the comma, and then I hit equals, which is up by backspace, and it just puts a little bar underneath. That's the way I like to do it. So let's try this one. 1 less than equal to x less than or equal to 5. Okay, so look at that. So two vertical lines at x equals 1, x equals 5. And then the other one, by the way, is a horizontal line, y equals 2, so that's our boundary line, and then it shaded everything below because all the numbers that are less than 2 are here, and then all the numbers that are between x equals 1 and x equals 5 are right in there, right? So this so far, right here, this little rectangle, I guess all of this stuff down here is our feasible region so far. But we're going to get another inequality, so let's do that one real quick. Y less than, I hit the equal sign, puts a little bar underneath, and then I go x plus 3, right? Okay, so now, where is our feasible region? Well, it's going to be, everything that's below this line, right? Everything that's between these two lines, and everything that's below the horizontal line. Oh, notice that? I put the wrong, because this would be an unbounded region. It just keeps on going down, which has me a little worried. That would be a weird problem here. So ultimately we want this bounded region right here. So I put the wrong inequality sign in there. So let's switch that, right? So greater than or equal to. So make sure that when you're looking at your feasible region, it's going to, for most of the problems, it's going to be a bounded region right here. And so what we're going to do is, it says right here, name the coordinates of the vertices of the feasible region. So there's one of them right there. There's another one. If you click on the screen, it's going to keep the points there. So we're looking for those intersection points, right? So here are our 4 intersection points for our feasible region. The next thing we're going to do is we're going to transfer those to our notes. So 5, 8, 1, 4, 1, all that stuff is going to get transferred over here to our notes. And the drawing is going to get transferred over to our notes. So let's go back over here and let's look one more time at our drawing. It's kind of this, I guess that's a trapezoid, right? It's a trapezoid shape, and I want to put that trapezoid right here. So let's see if I can do that real quick here. Come on. So I'm just going to draw it, and this is what I want you to do as well. Just freehand draw this. So let's see here. I think my pen tool is turned on. So let's see, how's that look? It looks kind of like this, right? Like a trapezoid right here. And we're going to highlight these points. Where are the vertices of our feasible region? So shoot, they turned off on me. 1, 4. So 5, 8, 1, 4. We want all these points right here. 1, 2. You might have to double click on them. 5, 2. So let's see if it'll stay over there once I start writing. It might not stay over there. 5. Oh, good, it did. 5, 2. And then we got 5, 8. And we've got 1, 4. And we have 1, 2. So our feasible region was this shaded region right in here, right? Because it was everything above the line. Initially, I had my inequality turned around there, so that was bad. So this was the line y equals 2, right? That's our horizontal line y equals 2. This is our vertical line x equals 1, and this is our vertical line x equals 5. So we practiced this stuff yesterday, but we didn't have too many vertical and horizontal line problems. We had a lot of, like this, where there was an oblique line that we had to graph, right? And so let's see, that one is y equals x plus 3, y equals x plus 3. They are all solid lines, by the way. I am dashing them past the feasible region, but I'd love for you to do this in your homework right here, is really label what these equations are. Remember, if we're going to graph an inequality, like you're going to graph x less than or equal to 5, let's say, so you'd say, well, what does the equation x equals 5 look like? And then that's that vertical line right there, x equals 5. Or if you're going to graph the inequality y less than or equal to x plus 3, first thing you do is you write y equals x plus 3, and you graph y equals x plus 3. So the y-intercept is 3, and the slope is 1. So that's what that should be doing right over here. Like there's 3, it's going up 1 over 1. Hey, I hope all this makes sense. I hope I'm not making this seem too difficult. So what we're going to do is we're going to transfer all these numbers to our table. So 1, 2, 1, 4, 5, 8, and the last one is 5, 2. And then let me just zoom in on this because it might be hard to see. So let's go full screen. We're done using Desmos for now, and we're going to stick these numbers into this equation here. This is the equation that we're trying to minimize or maximize. So shoot, I didn't make that clear. So what first you do is you pick the one that has these 4 points, right? So where are they? 1, 2, 1, 4, 5, 8, 5, 2. It's this one right here. It's B, okay? Then on part 2, or question 2, it's related to number 1. It says find the maximum and minimum values of the following function. So this is the part about optimization that we're talking about today. So let's look at my table. That's why I have 3x minus 2y right here. So you're going to copy this equation that they give you that they want you to minimize or maximize. You're going to copy that into that middle column. Okay, so every problem is going to have this little table here. You're going to list your optimization points that you're going to test. Those are the vertices. Let me just say that one more time. Those are the vertices of your feasible region. So I had 4 points here on my feasible region. So I need to test out 4 points to see which one's going to be the maximum or the minimum. Because that is the idea today, that once you graph your inequalities, the max or the min is going to happen at one of these points at the corners or the vertices of your polygon. It's not going to happen inside. The minimums or maximums are not going to happen inside. They're going to happen at those points over there. Okay, so let's go down here and let's try them out. So I go and I plug in 1 for x and I plug in 2 for y, and that's what I'm going to try to do right now. So I go 3 times 1 plus, oh, it's minus, hello, minus 2 times 2. Well, what does that give me? 3 minus 4. So I think I'm doing this right. 3 minus 4. Hopefully I don't mess up the arithmetic. I get -1. You try the next one out. 3 times 1 minus 2 times 4. Well, that gives me 3 minus 8. 3 minus 8 gives me -5. Let's try the next one. 3 times 5 minus 2 times 8. Let's see, I get 15 minus 16. 15 minus 16 gives me -1. And then down here I go, let me put my order pair on there, my parenthesis. 3 times 5 minus 2 times 2. That gives me 15 minus 4. 15 minus 4 gives me 11, right? So where is my minimum value? Oh, it's right here. That's my minimum value. Where's my maximum value? Oh, it's right there. okay? So that's how we finish this problem off, all right? So let's go back over here, and it says what's the minimum, well, let me see here. It says find the maximum and minimum values of the following function for the region. Oh, so I'd put negative, what was it again? Negative 5 in the minimum and 11 in the maximum. Make sure you put them in the right boxes. I was a little worried that they wanted the ordered pairs where they happen, you know, because they gave us this fairly large box to type in just one single number. So be careful on the homework. They might switch up the directions and say, where does the minimum happen or where does the maximum happen? It happens at 5 too, but I think they just want 11 right there, and they want negative 5 over here, okay? So today I'm not turning on, you know, check my answer. You don't have 3 attempts to do this, because Desmos is telling you, right? Desmos is telling you what the numbers are here. So I hope you don't just, you know, randomly choose numbers here to put over here. Hopefully you're getting the vertices of the feasible region. That's where the minimums and maximums occur. Hey, if you have any questions, call me over. I want to help you out. Thanks for watching my video.